from here and there channel. How the Mosul ferry capsized. Technical analysis. 2 years have passed since the accident. Happened on March 21, 2019. The official authorities have not released the technical investigation report to clarify what happened. Therefore, we publish this analysis based on the published videos in an attempt to find the truth. First, notes on the design of the ferry. Since the analysis is based on video clips, we will estimate the dimensions of the ferry as follows. The length is 8 meters. The width is 5 meters. The average height of the pontoon above the water is 50 centimeters. According to Archimedes' principle, the weight that causes the ferry to sink is 20 tons on conditions that water is still or flows at a low speed, based on the estimated dimensions, and without calculating any safety factor, which reduces the permissible load. The above-mentioned weight equals roughly to the weight of 300 passengers of different ages, with an average weight of 65 kilograms, or 250 adult-only passengers, with an average weight of 80 kilograms. Based on the previous conditions. Some important notes. In certain circumstances, the position of the guide cable connection acts as an axis of rotation for the ferry, because it is more than a meter above the water surface, cause the ferry to tilt around it. The returning pulling cable generates a lateral force when it touches the arched upper frame, which attempts to overturn the ferry, because it is elevated and passing in between the arches. The connection of the pulling cable with the ferry is not at the center line, but rather closer to the side, which makes all the cables on one side, reducing the stability of the ferry, and making the other side easier to rise from the surface of the water. Notice the presence of overhead wires connecting the parts of the upper arched structure, which may be used for lighting and or to connect the parts of the structure together. It had a role in the tilt of the ferry by preventing the returning pulling wire from being released and keeping it trapped in between the structure, causing the continuation of the force that caused the tilt the ferry until the breakage of the pulling cable. On the day of the tragic accident, the water level in the Tigris River and its velocity were high due to the opening of the gates of the Mosul Dam to absorb the wave of the flood. The business owners on the river were notified, according to the relevant authorities' statement, and a published document that has not been verified. Second, notice the previous trip of the ill-fated one, which gave indications of the severity of the situation. The number of passengers was small, ranging from 50 to 60 passengers only, which is much less than the number that causes drowning. However, 1. The water reached the upper edge of the ferry, which is an indication of the risk of increasing the number of passengers more than that. The number increased from 4 to 5 times in the last trip. 2. A noticeable inclination of the ferry from the surface of the water, and even the not loaded ferry to the left is inclined due to the speed of the water and the high level of the guide cable. 3. A noticeable deviation of the ferry from the straight course due to the velocity of the water in the middle of the river. These are serious indications of how dangerous it is to increase the number of passengers more than those in this trip. Before investigating the last trip, let's see this image, which is an old image that has not been verified. Notice the large number of passengers. From this image, we assume that the ferry was used to transport large numbers previously without sinking, and perhaps that gave a feeling that transporting large numbers is safe. However, this time the speed of the water in the river was high, which changed the result. Third, the last trip, the disaster. The number of passengers is about 250, of different ages, including children. Despite the dangerousness of the number, even in times of calm river, it may not cause the ferry to sink, but in the circumstances of the day of the accident, the great speed of water, the number caused a problem, as it is 4 to 5 times of the previous trip, in which the water reached the edge. The forces acting on the ferry that led to its capsizing. 1. Weight of the ferry. 2. Passengers' weight. The two previous forces acts downwards, causing an increase in the submerged depth of the ferry, but counteracting the tilting moment. 3. Water force. It is a major force in the accident. This force is proportional to the square of the water's velocity, so it increased dramatically on the day of the accident. As well, it is proportional to the vertical projected area of the submerged part, which led to the aggravation of the ferry's situation. The more it is tilted, the more it sink in the water to compensate for the decrease in the submerged volume. Thus, increasing the vertical projected area facing the water current, which leads to an increase in the water force, which in turn cause an increase the tilting angle of the ferry, and so on. 4. Lateral force resulting from the resistance of the guide cable. This cable acted as an axis, around which the ferry rotated because it is more than 1 meter above the surface of the water. 5. The lateral force resulting from the collision of the return pulling cable with the arched upper structure of the ferry. This force works with the force of the water momentum to generate a torque that tries to rotate the ferry around the guide cable, which acts as the axis of rotation as mentioned before. Finally, notice the welded plate. It looks that it was added to increase number of passengers by increasing the above water height. The added plate made the top of the pontoon as a reservoir that collect water which add additional weight, maybe between 500 to 1000 kilograms, unless there is a way to drain it. Let's follow the last trip that did not end at its destination. When this number of passengers boarded, definitely caused the ferry to descend into the water, but it did not cause it to sink, because the speed of the water at the sides of the river is less than its speed in the middle, and short length of the cables that connect the ferry to the installations at the riverbank. It does not mean that the ferry was safe, even that it did not sink. As the ferry advanced, it appeared to be unstable, and swaying aside, with a clear deviation from the straight path, as an indication of the great impact of water speed, the large number of passengers that is not commensurate with the condition of the river, in addition to the length of the cables connecting it, which gives it greater flexibility for lateral movement. Its drift increased as it advanced towards the other bank of the river, moving further out of its course, which required further lengths of guide and pulling cables. This may be the result of the cable's flexibility or a forced pulling of extra length from the equipment because of the huge thrust of water on the ferry, or it is a safety precaution or a procedure to ensure that the ferry do not capsize on a similar situation. The ferry rotated a little by little as the tow is on the other side, to head towards the arrival point. All this led to the collision of the upper pulling cable with the arched structure, generating a force that helped increasing the inclination, which became evident, and the water began to rise inward from the side of the cables. On the other side of the river, a number of people, seemed to be work observers from the tourist island staff, noticed the imbalance of the ferry and pointed by hands. The previous process transferred an important part of the load to the pulling cable, which is weaker than the guide cable. The previously mentioned effect of the collision of upper cable with the arched structure, which apply a force to the structure of the ferry, generating a torque together with the force of water momentum, causing the ferry to tilt markedly around the guide cable, which became an axis of rotation. When the ferry tilts and the other side raised, the volume of the plunged part decreases, causing it to go down further in the water to provide the difference, to achieve Archimedes' principle. The increase in the descent of the ferry in an inclined angle means an increase in the vertical projected area facing the water current, more than that provided if the ferry has a lower submerged part because it is horizontal or slightly tilted. It means an increase in the force exerted by the water on the body of the ferry, and thus pushing it more with the flow of water, which means an increase in the cable's tension. This leads to more increase in the inclination of the ferry, more descent in water, and the process continues until the force is balanced, the ferry capsizes, or, as happened in the Mosul ferry, one or more cables cut off. After the pulling cable cut off, forces were transferred to the guide cable, and as a result, stresses were generated on the columns to which it was connected, causing parts from them to fly off. The torque that tilt the ferry decreased because of the breaking of the pulling cable, causing the ferry to tilt in the opposite direction to return to the horizontal position. This would have helped in avoiding the disaster, but it was too late. The ferry was too close to the next ferry and landed on its cables. This prevented it from returning to horizontal position. The force of water and the cables of the other ferry generated a torque that led to its complete overturning and the detachment of the guide cable. The ferry drifted with the water. Many of the people on board lost their lives. Wait for the recommendations and conclusions in the next video from Here and There channel.